Question 32 basically talks about polynomial px, which is summation ai x to the power I running from 0 to n, and qx is the integral function from 0 to x, and rx is the derivative of the function. And V is the real vector space of all polynomials in X. And we have to check whether Q and R are linearly dependent or independent, and whether X to the power n and X to the power n plus 1, whether or not they belong to the linear span of Q and R. Okay. So, okay, and since Px, this is a factor we'll be using here, since Px is a polynomial of order n, then an not equal to 0. This is a fact we will be needing multiple times in solving this question. So I basically, in the first step, I'll simply obtain Qx, which comes out to be a naught x plus a1 x square by 2 plus dot 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 a n x to the power n plus 1 by n plus 1. And Rx comes out to be a1 plus 2 a2 x plus dot 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 n into x to the power n minus 1. And in order to check linear independence, we solve alpha qx plus beta rx equal to 0. If this implies alpha equal to 0 and beta equal to 0, then Q and R are linearly independent, else they are not. So alpha qx plus beta rx comes out to be this term, which is a1 beta, which is the constant term, a lot of other terms, and we just need the last three terms, which is alpha n minus 2 by n plus minus 1 plus b n a n x to the power n minus 1 plus a n minus 1 by n into alpha xn plus a n by n plus 1 into alpha xn plus 1. You can check this out by solving the first few terms and the last few terms. This will come out to be this particular form. And since this is equal to 0, we equate the coefficients of xn on both sides. So the coefficient of x to the power n is an by n plus 1 into alpha, which is equal to 0. So alpha is equal to 0 since an cannot be 0. Similarly, for x to the power n minus 1, alpha into n minus 2 by n minus 1 plus n beta n an is equal to 0. And since from this step alpha is equal from here alpha is equal to 0, this entire thing comes out to be 0. This entire thing is 0. An is non-zero and n is obviously non-zero. So beta is equal to 0. And therefore, we have obtained that Q and R are linearly independent by the definition of linear independence. And next, we have to check whether x to the power n and x to the power n plus 1 belongs to the linear span of Q and R. So we first assume that x to the power n belongs to the linear span, and we write x to the power n as alpha 1 qx plus alpha 2 rx. It comes out in this form, similar to the previous form we have obtained. And from this form, we equate coefficients of x to the power n and x to the power n plus 1 on both sides. Obviously, on the left side, we have simply x to the power n, so its coefficient is 1. So 1 is n minus 1 by n alpha. So alpha is n by n minus 1, which is not equal to 0, since obviously n is greater than 0. However, when we try to equate the coefficient of xn plus 1, we see that 0 is equal to an by n plus 1 into alpha. So alpha is equal to 0, since an cannot be 0. So it's a contradiction, and C is false. And we can similarly show D by checking the coefficients of these two terms again, where we can take x to the power n plus 1 as some beta 1 px plus beta 2 rx. So B, C, D, and are all false, and thus A is the only correct option. Okay.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Let me move to the next question. And now this is a type of question you can very often expect in IIT examination, particularly in the MSQ parts, because in nowadays they usually give questions where you need to verify all the options for a given random variable, or maybe even for a mathematics problem. You need to check all four options separately, and some of them may turn out to be the answer. So here we are given x and y, which are two IIT binomial NP random variables, and we have to check four options, which of them are true. So the first option is x plus y follows binomial 2n comma p. So obviously that's a very trivial problem because it directly follows from the additive property of the binomial distribution. So x plus y definitely follows binomial 2n comma p. The next question is xy follows multinomial 2n pp. So essentially it's a trinomial distribution. However, since x and y are independent, they cannot jointly form a trinomial distribution or a trinomial distribution in this case, because in a trinomial distribution, the two random variables x and y are dependent by the factor that x plus y less than equal to some n. And the third option is variance x minus y is equal to expectation x minus y whole square. Now, variance x minus y can be written down as expectation x y. Okay, second. So variance x minus y. So variance x minus y is expectation x minus y whole square minus expectation square x minus y, which is the formula of variance for any given random variable. And that comes out to be expectation x minus y whole square, because obviously expectation x minus y is expectation x minus expectation y, which is 0 since x and y are IIT random variables. Okay. And in part 4, we have to check whether covariance x plus y and x minus y is equal to 0. So covariance x plus y and x minus y, this actually comes out to be this thing. It's variance x minus covariance xy plus covariance xy minus variance y. So it's just variance x minus variance y, which comes out to be 0 since again x and y are IIT. So A, C, and D are the correct options, and B is wrong here. Okay, so